Last thing I wanted to talk about is the critical path method. This is a little bit out of place here because it's not really a system reliability approach. It's a project planning approach. But I didn't quite, it might be better placed in decision analysis. I was thinking about that yesterday. But I thought I'd toss it in here because it's kind of networky. So I put it in here just for that reason. Just because of the superficial similarity, but it's really a decision analysis project planning technique. It's an algorithm and it's graphical. And what we do is we have activities and that are part of the project. And that's really we need to get off of that slide. You can look at it later. That's sort of and what you do with each one of the activities is you determine how long is required. The minimum amount of time is to perform the activity, and what has to precede it, and what has to succeed it in your process plan in order for it to successfully occur. So the first thing you would do is to develop a set of activities like this. And you can identify them, but for instance, A and B have no predecessor. Develop a system safety program plan, develop initial hazard identification. Okay? This requires 24 days, this requires 7 days. But you can do those simultaneously because they have no predecessor. Nothing needs to precede it in the process. Develop preliminary hazard analysis can't occur until after B. And that lasts 22 days to do it. Develop preliminary energy hazard analysis also has to occur after B. Develop preliminary risk analysis has to occur after you completed D. Assign appropriate personnel has to occur after you finish A. You can kind of see where this is going here. Conduct your audit occurs after you've done F. Initial safety. Develop initial safety design has to be done after C, E, and F, and then conduct concept design review has to occur after G and H. So each of these has a predecessor and it has a duration associated with it. What the objective of this method is to try to define what the critical path is. In other words, what do we have to do exactly on time in order for the project to be completed in the time allotted, in the time that we estimate. And to do that, you use a graphical approach. So first thing you do your network model and your critical path, and then what you need to do is the earliest finish, latest finish, the slack, which I'll define, and it's probably pretty obvious, earliest start and the latest start for each one of the activities. Okay? Now, first thing you do is you take an activity. Okay? Activity is a letter and it has a duration. And you place it over an arrowed line in the direction. Then you have a beginning and end point. And these are arbitrary designations. Okay, so node 8 and node 9 are connected by some activity M, which has a duration of 5. And like I said, the 8 and the 9 are arbitrary. We just use nodes in order to provide a point of reference. This is, we do, well, after we've finished Q, which takes 4 units of time, we go through node 9, arbitrary, and it has to and Q has to precede R, which takes 10 units. Okay? All this indicates is that Q must precede R. It's its predecessor. Here, S and T both have the same predecessor R, and they branch off into their own nodes. S has 8, R requires 10 time units, S requires 8, and T requires 5. However, these S and T can be done simultaneously as long as R is completed. And so those are simultaneous tasks. here we have U and V, which can be done simultaneously, but both U and V must be done for W to occur, and also U and V must both be done for X to occur. So at this node, we have two parallel activities, and each of those parallel activities precede both of the parallel activities that exit from that node. So both of these activities, which can be done in parallel, have these two activities as predecessors. This is what's called a dummy activity, and we'll talk about it a little bit later, but here we have a predecessor for A and a predecessor and Y is a predecessor for B. However, you can put in this dummy activity, and you see this is the same node number. A dummy activity because of the fact that A does not have Y as a predecessor and B does not have Z as a predecessor. However, they both have to be complete. So it's not a predecessor, but it has to be complete. It's a subtle difference, but nevertheless important. And it indicates dependency, although it doesn't have any time associated with it, the dummy activity. So this is our network. Node 1, we just start out arbitrarily, and A and B branch off because they have no predecessors. A takes 24, B takes 7. Then we go to C. C has B as a predecessor. Okay, so here's C, and it lasts 22. D has B as a predecessor, so it branches off. It can be done in parallel with C. E has D as a predecessor, so it branches off here. H has C, E, and F. Okay, so here's F, here's C, and here's E. That's why we put in a dummy activity there, because it has that as a predecessor. G has only F as a predecessor, but H has both C, E, and F as a predecessor, so we can put it on a node with C and E, but we have to put a dummy activity in there with F because G doesn't have those two as predecessors. That's why that dummy activity is there. Then J has G and H as predecessors. Again, these nodes, we could just as easily not put numbers in there at all. It would serve the same purpose. We don't really need the node numbers. But J is the final activity here, which then finishes our task. Did I leave J off?
Yes. or that's just I.
H. Oh yeah, it is.
J is I.
Yeah. I can check myself. Yeah, that's an I. Not a very good I, but yeah, that's an I that I'm misreading. So anyway, that's I, and that has G and H as predecessors.
If you're going to draw one of these, is it easier to start at the end and work backwards?
Yes. Yeah. That's usually the best way to go with this, is to work backwards. Because in one of the calculations, that's exactly what you do, is you work backwards with it. So, first thing you do is enumerate your paths. Okay, A, F, G, J. That's an easy path. And just add up the number of days required. Then we can go A, F, H, J. That's 57 days. That's all we can do this way. This way we go B, C, H, J. That's 52 days. And B, D, E, H, J, I. Keep calling it I. I even put J there. I and J, they're interchangeable, okay? So the B, D, E, H, J is 56 days. Okay? So, the critical path is for everything to be completed in time is A, F, H, and J. A, F, H, and J you recall, is 57 days. It's the highest number. Okay. These can, all these can be completed in, and AFHJ, this longest path, if you don't make that one, the one with the longest duration, that's the one that's going to cause the project to go off schedule. All of these other ones have slack built into it. Okay? This path has 9 days slack built into it. This path has 5 days slack. This path has 1 day slack. This path is the critical path that it requires the greatest amount of time. It has no slack built into it. And that means that all the activities have to be completed in time. So the first thing that we do is we calculate, we have this little, and there's a number of different ways, notation that you can use for this. But one of the notation is to put a little set of boxes, where there's 2 boxes with one above it. Okay, the lower left box is called the earliest finish. It's the earliest time that each activity can be finished. So this one's not bad. So we go to A, we know that that has to be completed in 24 days. F, since A is its predecessor, can be completed in 34 days. G, since A and F are its predecessors, 34 plus 11 is 45, and then J is 45 plus 3 is this is 57 because it's on the critical path. So we can't just go ahead and add 3 to 45. We have to go to our critical path. So we'll stop at G. This one, that's 7. Go along this path, plus 22 is 29, plus 29 plus 20, you would think is 49, but 34 is longer than 29, so 34 plus 20 is 54. And now we're on a critical path. That's 54 plus 3 is 57. Go to our other path, which is 7 plus 8 is 15, plus 18 is 33. But again, you don't add 20 to that because you've already gone through across the critical path and got 54 to get 57 there. So that is the earliest finish. It's the earliest start time plus activity duration. Earliest start time meaning whatever the limiting path is. And if it's not along the critical path, then you can't start it until that activity is finished.
So when you're filling this out, it'd be better to fill out the critical path first,
yes,
and then fill in the blanks, basically.
That would be by far the best way to do it. Yeah, because we've already determined that our critical path is AFHJ, or FHI, whatever. So A, F, H, I. And you can go along that one and fill it out, and then go back and fill the other ones out. Because if something's already filled in, then you don't need to
Just skip
redo
it.
it. So that's what's referred to as the earliest finish, and that's in the lower left-hand box. I'll start a little legend here. We have the top box, and we have lower boxes, and that was the earliest finish. So if we look at to node 6, I don't know why I called that event. I should have called that. Oh no, event. That's right. These nodes are called events. So we go to 6, event 6. You can get there by BC. You can get there by BDE, B, D, and E, or you can get there by A and F. Okay? You can get there, and the duration for each one of these is 29, 24, let's see, for A and F it's 24 and 10, that's 34. For B, C, that's 29, It's this one in BDE is 7 and 15 and 18 and 33. Okay? So that means that you can't, this particular one can't start until day 34. That's the earliest finish for that one. That's multiple, because we've got multiple things feeding into it. Okay, so this is just another way of thinking about the critical path, although really doing the critical path first and then going back is probably the most efficient way. But this is just a number of ways, another way to think about it. If we're going, this is probably more algorithmic. If you were writing a program to do this, you probably would want to do it this way, is to calculate all of them and then take the one that's greatest for that to move onward to 34. And then in the lower right box, we have latest finish. Okay. So, 24, 34. However, here, since this is on the critical path, and that's probably the best way to do this, is to take the critical path and go backwards. Okay? This is our critical path is A, F, H, and I. Okay? Since that's our critical path, the latest finish and the earliest finish are going to be the same. That's how you trace that. So I'll call the critical path red. Like I said, you have to note that the earliest finish and the latest finish are identical. And you probably guessed that what goes up here is the slack, which is the difference between earliest and latest finish. The slack on these is 0. It means you have to do it to keep your project on time. So along the critical path, your slack is 0. Latest finish, the best thing to do is to work backwards. Okay. That's to start up here, and so that means that the latest that this one can finish is, since I am waiting for this to occur, this one can wait until 54 to start. Okay, 3 from 57 to 54, or 3 from 57, that makes that 54. This one can wait for, that's not, till 34, because 54 minus 20 is 34. This one can wait till 34, because 54 minus 20 is 34. And this one, 34 minus 22 is 8. And 34 minus 18 is 16. 16 minus 8 is 8. So 22, it's 12. This 8 comes from there. 16 minus 8 is 8. So those are the latest finishes. So 34 minus 22 is 12. Actually, it can't, because this one would have to be from this path right here. So that would be 16 minus 8 is 8. So then we have slack associated with the other paths, and that slack is what goes in the top box. This one has 9 slack. This one has 1 day slack. This one has 5 days slack. This one has 1 day slack, and this one has 1 day slack. Okay, so you can tell how much extra time you have on those other activities that way, that are off the critical path. And I kind of think I already went through that in a kind of a clumsy way, but this is sort of the algorithm that I just went through. So you can refer to that then, when looking at this later. And then slack is just latest minus earliest. I filled it in there. And then for this part of the activity, or this part of the algorithm, you can put it back in a table. It's probably the easiest way to approach this. Because we've already got earliest finish, latest finish, and slack. The earliest start is the earliest finish minus the activity duration. And the latest start is the latest finish minus the activity duration. So it gives you a table then of how long you can wait to start each activity. And if you look along our critical path, which again was let's see, AFHJ. Okay, so you look along AFHJ, you can find that the slack is 0 for each one of these. Mm-hmm. The earliest start and the latest start are the same. Earliest finish, latest finish are the same. And for each one of those, and slack is 0. Except for the last one, of course, because that's the final activity. But we really can't start that until we finish the previous activity. So like I said, this is something that you don't really want to spend a lot of time with by hand. There's a lot of critical path software available that will do this for you. But I think that this is an interesting planning and decision-making method that's used pretty commonly. This and PERT and Gantt charts is another approach to project planning. I think those are a little more common than the critical path is, because they're a little bit more intuitive, I think. Because you can make a Gantt chart really easily by just using Excel and filling in the cells, and it comes out to essentially the same answer. But this is I think kind of an elegant approach to project planning. Questions?
Have you ever worked with Microsoft Project?
I haven't, no. Does it use this approach, or does it use a Gantt?
It's got options.
Oh, it does?
Yeah,
Okay.
but your critical path will always be if you like select display full project, let's say you're building a house, it'll color code your critical path, and you make decisions based on whether things are kind of left or right of that line.
Yeah, it sounds.
Yeah, it's the same stuff.
Yeah, yeah. And there's all kinds of variants on this. Like I said, PERT is one which is very identical, or very similar to CP, the critical path method. And there's Gantt charts and all that sort of thing. I haven't used Microsoft Project. Yeah, no, I haven't used it. But that will do much of the same stuff for you. Okay. Well, if no one has any questions, that's all I have to talk about. I'll start next week doing the problems for this week, and then we will go on. Oh, That's right, before I forget. For simulation, does everybody have a laptop that you can bring along to class? Does anybody not?
I don't know if I'll have one yet. My computer died last week.
Oh.
I'm waiting on a new one.
Okay, well, let's hope that you have a new one. Because what I'd like to do is some really basic, is after we go over the practice problem sets, is to do some really basic, let me reword that, introductory basic programming, because I hate to say basic programming, introductory basic programming. And if you all have your laptop in front of you, you all have Excel, I'm sure, and everybody loads Microsoft Office, we can do a little bit of programming, and that's a good way to start off that topic. Let me look at it first.
Is that for next week?
That's what I was just going to say, whether or not I started off with it. Actually, in 2 weeks is when we'll do that, after we've had a chance to talk about the next week's topic. So 2 weeks, so I think you're okay, Taylor. So 2 weeks, make sure you have your laptop with you, and we'll be able to use it for that. Okay. We don't have any questions. That's all I have for today.